Good morning. Today, I welcome you all to the training classes conducted by the Government of Karnataka with the collaboration of Department of Pre-University Education for CET NEET 2018-19. Today, myself, Rajeev Naregal, Senior Lecturer in Chemistry, going to discuss three important units in physical chemistry. These three topics come in first year PUC syllabus. The first unit is some basic concepts of chemistry. Second one, structure of atom. The third unit is classification of elements and periodicity in properties. All the three units are equally important from the examination point of view. They are so important because you see any CET examination paper, a NEET question paper or JEE main or advanced question paper, you will find questions from all the three units repeatedly asked in the exams. Minimum of 4 to 5 questions will be there. Therefore, it becomes even more important for any student to give prominence and understand these subjects. Therefore, to start with, the basic concepts of chemistry, the synopsis. I have made an effort to cover all the important points so that any student who goes through these definitions, formulas which are given in synopsis can help a student to understand the subject and answer the questions easily. Some important terms I have selected. Precision to start with. Precision refers to the closeness of various measurements for the same quantity. Accuracy, it is the agreement of a particular value to the true value of the result. Significant figures, the total number of digits in a number including the last digit whose value is uncertain is known as significant figures. There are different laws of chemical combinations. There will be questions on these laws of chemical combinations. The first one is law of conservation of mass. It says matter can neither be created nor destroyed. Law of definite proportion says a given compound contains exactly the same proportion of elements by mass. Law of multiple proportions, the statement goes like this: if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in simple whole number ratio. Gay-Lussac's law of combining volumes, which is also known as law of definite volumes, the statement goes like this: when gases combine or are formed in a chemical reaction, they do so in a simple whole number ratio by volume. Avogadro's law, at the same temperature and pressure, equal volumes of gases contain equal number of molecules. All these laws are important in understanding the chemistry properly. Atomic mass, it is the ratio of mass of one atom of an element to 1/12 the mass of one atom of carbon-12. Atomic mass unit is known to you. Atomic mass unit is 1/12 the mass of one atom of carbon-12 and its value is equal to 1.66056 into 10 power minus 24 grams. Using this AMU, the atomic mass of an element is calculated. Molecular mass is the sum of the atomic masses of elements present in a molecule. Mole concept, we understand it is the as many particles as there are atoms present in 12 grams of carbon-12 isotope. Therefore, 1 mole of particles is equal to 6.023 into 10 power 23 particles, or if it is a gaseous or vapor, then at STP 1 mole of particles occupy 22.4 liters. Therefore, we understand that what is known as molar mass molar mass is mass of 1 mole of a substance in grams, and molar mass is connected to gram atomic mass, gram molecular mass, gram formula mass. How? Molar mass is equal to gram atomic mass for an element, molar mass is equal to gram molecular mass for an element or a compound, molar mass is equal to gram formula mass for ionic compound. Therefore, we can conclude that 1 mole of particles contain Avogadro number of particles and weigh molar mass and occupy 22.4 liters if it is a gas or vapor at STP. You can understand from this statement I have just now made, 1 mole of particles is related to Avogadro number of particles is related to molar mass is related to what is known as molar volume. Using this, you can calculate mass of one atom, mass of one molecule, number of moles, and the amount of the substance, and they are because interrelated with one another. Limiting reagent. The reactant which gets consumed and limits the amount of product formed in a reaction is known as the limiting reagent. Concentration of a solution, otherwise also known as the strength of a solution, can be expressed as parts per million, mole fraction, molarity, and molality. ppm, parts per million, is known to you. It is the number of parts by mass of a solute present in 10 power 6, that is 1 million parts of solution. Mole fraction can be stated as the ratio of number of moles of a solute to the total number of moles of solute and solvent in a solution. Molarity is the number of moles of the solute present in 1 liter of a solution. Likewise, molality is defined as the number of moles of a solute present in 1 kilogram of the solvent. So these are all the important terms, definitions one has to go through and understand in the first unit of physical chemistry. The second unit is about structure of atom. Again, I have made an effort to select some of the important terms and theories that we come across. To start with, the Thomson's model. It says about the structure of atom. Atom is made up of positive charge, and the negative charges, namely the electrons, are embedded in the positive charge. The Thomson's model is also known as plum pudding model. Rutherford's atomic model. Rutherford conducted alpha ray scattering experiment. On the basis of alpha ray scattering experiment, he made some of the observations which we now consider them as the postulates. The important ones are the positive charge and the most of the mass of the atom was densely concentrated in extremely small region called the nucleus. Diameter of the nucleus is of the order of 10 power minus 15, and diameter of the atom is of the order of 10 power minus 10 meter. The number of protons in the nucleus is equal to number of electrons outside the nucleus. Electrons and the nucleus are held together by electrostatic forces of attraction. When Rutherford proposed his model, the neutrons were not yet discovered, and Rutherford's model was not stable. It was proved wrong, and thereby the further atomic models were put forward. Before going to the next model, let me give you the definitions of some other important terms that we come across. Atomic number, it is the number of protons present in the nucleus of a neutral atom. Mass number, it is the total number of protons and neutrons present in the nucleus of an atom. Atomic number is normally indicated by Z, and mass number is indicated by A. Isotopes are the atoms of the same element with same atomic number but different mass number. Isobar, elements having the same mass number but different atomic numbers. So you should know the difference between isotope and isobar. Even there is one more important term that you come across is isotone. These are the elements having the same number of neutrons, and they differ in the number of protons. In otherwise, they differ in mass number. Isoelectronic species, atoms or ions having the same number of electrons are known as isoelectronic species. Bohr's model of hydrogen atom. Bohr, after studying quantum mechanics, he considered and put forward his idea about the structure of atom, hydrogen atom. According to Bohr, the electrons revolve around the nucleus in a closed concentric stationary energy levels, also known as orbits. The angular momentum of electron is quantized, that is, angular momentum of an electron is given by nh by 2 pi, and electron can jump from lower energy state to higher energy state only when it absorbs energy, or it can jump from higher energy state to lower energy state only when it radiates energy. And the important formulas that you come across in Bohr's model, first one, angular momentum, mvr is equal to nh by 2 pi, where the values of n are 1, 2, 3, etc. Bohr's radius can be given by Rn, which is equal to R naught into n square by z, where R naught is equal to 0.529 into n square by z. Energy of electron in nth Bohr's orbit is given by En is equal to minus 13.6 z square by n square electron volt per atom. Potential energy is given by minus z e square divided by 4 pi epsilon naught r. Electromagnetic radiations. What are these electromagnetic radiations? They are made up of electric and magnetic fields oscillating perpendicular to each other and to the direction of propagation. Electromagnetic radiations are associated with some important characteristics. They are wavelength, frequency, velocity, and wave number. These definitions are already known to you. Wavelength, indicated by the symbol lambda, it is the distance between two neighboring crests or troughs. Frequency, symbol for that is nu. It is the number of waves passing through a point per second. Velocity, c, it is the distance travelled by a wave in 1 second. Wave number, indicated by the symbol nu bar, it is the number of wavelengths per centimeter. And we now understand there are different spectral series, namely Lyman series, Brackett series, Balmer series, Paschen series, and Pfund series. These spectral series are found in different regions. Lyman series found in UV region, Balmer in visible region, Paschen, Brackett, and Pfund series are found in infrared or IR region. The number of spectral lines, before going to the number of spectral lines, let me tell you, the wave number of the spectral line is calculated by the formula RH, which is Rydberg constant, into 1 by n1 square minus 1 by n2 square. RH is equal to 109.67800 per meter, or 1.096780 into 10 power 7 per meter. For Lyman series, n1 is equal to 1, n2 is equal to 2, 3, 4, etc. Likewise, you can understand for different spectral series. To calculate the number of spectral lines, when the final state is the ground state, that is n1 is equal to 1 and n2 is equal to n, number of spectral lines is given by the formula n into n minus 1 by 2. When the final state is not the ground state, that is n1 is not equal to 1, the number of spectral lines is given by the formula n2 minus n1 into n2 minus n1 plus 1 divided by 2. These two are the important formulas. Questions on this are repeatedly asked in NEET and CET exams. Therefore, any student has to concentrate on these formulae. Debroglie relationship, which talks about the particle and the dual nature of the electron, which says matter exhibits particle and wave-like properties. That is, lambda is equal to h by mv. Lambda is the wavelength, h is Planck's constant, m is the mass, and v is the velocity. Heisenberg's uncertainty principle. It is impossible to determine simultaneously the exact position and exact momentum of an electron. A nodal plane or nodal surface is a plane in which the probability of finding an electron is 0. Therefore, we further proceed to understand the important terms. Total number of electrons in the nth orbit, number of electrons in the nth orbit is equal to n square. Number of orbitals, let me repeat this. Total number of orbitals in nth orbit is equal to n square, and total number of electrons in nth orbit is equal to 2n square. Pauli's exclusion principle. The statement goes like this: no two electrons in the same atom can have the same set of 4 quantum numbers. So, we proceed to the next rule, namely the Hund's rule. Electron pairing does not take place in the degenerate orbitals until all the orbitals contain 1 electron each. Aufbau principle. Electrons enter in the subshell of an atom in the increasing order of energy. Quantum numbers. There are 4 important quantum numbers. One gives the energy and the distance of the electron, which is principal quantum number. Azimuthal quantum number L shows the orbital in which the electron is present, and L can have the values as 0, 1, etc. up to n minus 1 for a given value of n. Magnetic quantum number gives orientation of orbitals, and whose values are m is equal to minus L to 0 to plus L. Spin quantum number S describes the spin of electron about its own axis. The values of S can be either plus of or minus of. The third unit, the important postulates. There are the theories on periodic table. The first one is based on the Mendeleev's periodic law. Physical and chemical properties of elements are periodic functions of their atomic weights. Based on this, Mendeleev constructed periodic table, which was famous and known as Mendeleev's periodic table. Today we have the long form of the periodic table, which is based on modern periodic law. The modern periodic law says physical and chemical properties of elements are periodic functions of their atomic numbers. The long form of the periodic table is constructed on the basis of electronic configuration of atoms. There are 7 horizontal rows or periods, 18 vertical columns or groups in the long form of the periodic table. In the long form of the periodic table, the elements are classified into 4 blocks, namely S, P, D and F block elements, depending on the type of atomic orbitals that are being filled with electrons. Atomic radius, it is the distance between the center of the nucleus to the outermost shell of electrons. How does it vary? The variation of atomic radius. Atomic radii decrease with increase in atomic number in a period, that is across the period from left to right. And going from top to bottom in the group, atomic radii of elements increase. There are several factors which are responsible for the decrease across the period and increase down the group. Ionization enthalpy, it is the amount of energy required to remove an electron from an isolated gaseous atom in its ground state. Generally, we understand that ionization enthalpy increases along the period, that is left to right along the period, and on moving from top to bottom, ionization enthalpy decreases. Again, you should know there are several factors which influence the variation of ionization enthalpy. The various factors are screening effect, nuclear charge, and the nature of the orbital in which the electron is present. Electron gain enthalpy, it is the enthalpy change accompanying the process when an electron is added to a neutral gaseous atom to convert it into a negative ion. Generally, electron gain enthalpy on moving across a period, the magnitude of electron gain enthalpy increases. Down the group, the magnitude of electron gain enthalpy decreases. I am specifying the word magnitude because the number, the magnitude is more for that with a negative sign. So therefore, instead of getting confused, you understand the magnitude of electron gain enthalpy increases, and down the group magnitude of the electron gain enthalpy decreases. Among the halogens, how does this electron gain enthalpy vary? It is found that fluorine electron gain enthalpy is less than that of chlorine, which is less than or greater than that of bromine, and greater than that of iodine. Let me repeat, the electron gain enthalpies for halogens: fluorine less than chlorine, greater than bromine, and greater than iodine. Electronegativity, very important term that you have to concentrate. The tendency of an atom to attract the bond pair electrons, also known as the shared pair of electrons, towards itself in a bonded compound. While moving across a period, the electronegativity increases, and down the group electronegativity decreases. So you understand that fluorine in the periodic table is the most electronegative element. Now we shall start with the questionnaire. The first question I have selected is already displayed on your screen, and the question is like this. Two students performed the same experiment separately, and each one of them recorded two readings of the same mass, which are given below. Correct reading of mass is 3.0 gram. Mark the correct option out of the following statements using the data given below. Student A performs the experiment, finds the values as 3.01 and 2.99. Student B performs the experiment, finds the values 3.05 and 2.95. Using this, the question asked, results of both the students are neither accurate nor precise. Results of student A are both precise and accurate. Results of student B are neither precise nor accurate. Results of student B are both precise and accurate. And you should notice that student A has performed this experiment to get the values 3.01 and 2.99, which are very close to each other, and they are accurate or agreement with the actual value, that is 3.0 gram. Therefore, answer for the question is B, and the experimental percentage error is very little. Therefore, we consider the recordings of student A are both precise and accurate. The next question. What will be the molarity of a solution which contains 5.85 grams of sodium chloride per 500 ml of the solution? Options given: A 4 mole per liter, B 20 mole per liter, C 0.2 mole per liter, and option D 2 mole per liter. The question is on molarity. Molarity can be calculated by the formula molarity M is equal to NB by V of L. What is NB? Number of moles of the solute. So NB is equal to, NB is calculated by the formula W by M. What is W? Mass of the solute divided by molarity. Volume in liter. Volume in liter is equal to volume in ml divided by volume in ml. So it get cancels, you get this volume in liter. So therefore, you now find the answers I have calculated. It is given like this: molarity NB by V, where NB is WB by MB, and molarity is equal to 5.85 divided by 58.5, and for volume you have to convert this volume given in milliliter to liter. Therefore, divide by 1000, 500 by 1000 liter, and what you get is the number of moles as 0.1 and the volume as 0.5 liters. Therefore, the answer you get is 0.2 mole per liter, and the correct answer is option C, that is 0.2 mole per liter. 500 ml of a 5 molarity solution is diluted to 1500 ml. What will be the molarity of the solution obtained? Different options are given. Option A 1.5 mole, option B 1.66 molar, option C 0.017 molar, option D 1.59 molar. The dilution formula one has to understand is M1 V1 is equal to M2 V2. So, if you assume these two as M1 V1 and this will be V2, therefore, you have to calculate M2, that is M1 V1 divided by V2. So, this is equal to 500, M1 is 5 molar by 1500. So, the answer I have calculated using this formula, and you find the answer is 1.66, and therefore, the correct answer is given in option B, that is 1.66 molarity. We shall go to the next question. The number of atoms present in 1 mole of an element is equal to Avogadro's number. The statement is given very clearly. Understand, 1 mole, it says 1 mole is equal to Na atoms. Which of the following elements contain the greatest number of atoms? So, the question is based on mole and atoms, therefore, convert the masses of these species given into number of moles. So, how to calculate? So, 4 grams of helium, number of moles N is equal to 4 divided by 4 grams, that is equal to 1 mole. For sodium, N is equal to W by, that is mass of the solute, that is sodium, divided by number of moles, molar mass I mean to say, that is 23, 46 by 23, that is equal to 2. For calcium, it is found to be 0.4 divided by 40, found to be 0.01, and for helium, it is, let me do this calculation, 12 for helium, 12 divided by 4, that is 3 moles. So, 1 mole contains Avogadro number. In case of option A, you find 1 mole. For option B, it is 2 moles. For option C, it is 0.01 mole. For helium, the answer is found to be 3 moles. So, 3 moles should contain Avogadro number, and this answer is calculated already, you can notice it, and the answer is 12 grams of helium, which corresponds to 3 moles, and therefore, D is the correct option. This is the correct option you find. And go to the next question. Which of the following statements about compound is incorrect? A molecule of a compound may have atoms of different elements. B. A compound cannot be separated into its constituent elements by physical methods of separation. Option C. A compound retains the physical properties of its constituent elements. Option D. The ratio of atoms of different elements in a compound is fixed. Now, these are the different options given for the question asked above. What is that you find? Option A, B and D are found to be the properties of the compound, whereas option C you look at very carefully, a compound retains the physical properties of its constituent elements. It is absolutely wrong. Elements will lose their, atoms of elements will lose their properties when a compound is formed. For example, hydrogen is inflammable, oxygen is a good supporter of combustion, whereas water, which is formed by the combination of hydrogen and oxygen, is used to extinguish the fire. Therefore, the hydrogen and oxygen have lost their properties during the formation of the compound water. So, therefore, the answer you may find is in option C, that is, a compound does not retain the physical properties of its constituent elements. In other words, the atoms will lose their properties when compound is formed. Which of the following statements indicates that the law of multiple proportions is being followed? Option A. Sample of carbon dioxide taken from any source will always have carbon and oxygen in the ratio 1:2. When you read this question, you clearly understand that this question is based on law of definite proportions. Carbon forms two oxides, namely carbon dioxide and carbon monoxide, where masses of oxygen which combine with fixed mass of carbon are in the ratio 2:1. This is exactly what the answer for the given question. So, Here mass of one element, namely carbon, is fixed, whereas the mass of oxygen in carbon dioxide and carbon monoxide is in the ratio 32:16 or 2:1. So therefore, you understand this is the required answer for the given question. Option C is about law of conservation of mass, whereas option D is about law of definite proportions or Guy-Lussac's law. So you find I have already given the answer for you. The statement indicates for option B, the statement indicates that the law of multiple proportion is followed. Go to the next one. Which of the following conclusions could not be derived from Rutherford's alpha particle scattering experiment? Option A, most of the space in an atom is empty. Option B, the radius of the atom is about 10 power minus 10 meter, while that of nucleus is about 10 power minus 15 meter. Option C, electrons move in a circular path of fixed energy called orbits. Read it once again. You may notice something which is not the observation made in Rutherford's model. Electrons move in a circular path of fixed energy called orbits. So this is one of the postulates that you come across in Bohr's atomic model. Therefore, I find the answer is in option C, that is electrons move in a circular path of fixed energy called orbits is incorrect statement that is made or not made in Rutherford's atomic model. So option C, the scattering experiment gave no idea of the electron orbits. The next one, which of the following options does not represent ground state electronic configuration of an atom? Option A, 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. It refers to which element? You understand? Think about that. 1s2, 2s2, 2p6, 3s2, 3p6, 3d9, 4s2, 29 electrons. In the first case, it is 28 electrons. Option C, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1, 29 electrons. Option D, 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. You may find which is not the option or which of the following option does not represent ground state electronic configuration of an atom. I find the answer is in option B, because for the element with atomic number 29, namely copper, the electronic configuration should be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1 instead of 3d9, 4s2. Reason for that, there is a deviation from the above principle in order to attain extra stability. And we shall go to the next one. Which of the following statements about electromagnetic spectrum is not correct? Infrared radiations have larger wavelengths than cosmic rays. The frequency of microwaves is less than that of ultraviolet rays. X-rays have larger wavelength, larger wave number than microwaves. Whereas option D talks about the velocity of X-rays is more than that of microwaves. The question is about incorrect answer. Therefore, the answer is in option D. Velocity of X-rays is more than that of microwaves. X-rays, microwaves, gamma rays, they are all electromagnetic radiations. All electromagnetic radiations travel with the same velocity of light, that is 3 into 10 power 8 meter per second. And therefore, I have given the answer as option D, and the explanation is also there. X-rays and microwaves in fact are all electromagnetic waves, travel with the velocity of light, and the value is 3 into 10 power 8 meter per second. The nitride ion in lithium nitride is composed of, in the next question, the question is based on lithium nitride, where you are asked to calculate the number of protons and electrons in the nitride ion. Lithium nitride formula can be written as Li3N, lithium nitride, which contains nitride ion in the ratio N3 minus. So number of protons, Z is equal to 7 for nitrogen, and number of electrons for this particular compound is 7 plus 3 extra electrons you have, that is equal to 10. So I have given this answer In the next slide you find the answer for nitride ion is, the formula for nitride ion is N3 minus, the number of protons is equal to 7, the number of electrons is equal to 7 plus 3, that is equal to 10. So therefore nitride ion contains 7 protons and 10 electrons. The next question is about atomic structure. The energy of E1 and E2 of two radiations are given as 25 electron volt and 50 electron volt respectively. The relation between their wavelengths, that is lambda 1 and lambda 2, will be lambda 1 is equal to lambda 2 by 2, option B, lambda 1 is equal to lambda 2, option C, lambda 1 is equal to 2 lambda 2, option D, lambda 1 is equal to 4 lambda 2. The answers I have given: E1 by E2 is equal to lambda 2 by lambda 1, or E1 is given as, E1 and E2 values are given as 25 electron volts and 50 electron volts. Substitute the values in this expression. 25 by 50 is equal to lambda 2 by lambda 1, or simplify, you get lambda 1 is equal to 2 lambda 2. Therefore the answer is in option C. So therefore we go to the next question. Which of the following orbitals will have zero probability of finding the electron in YZ plane? To answer this, you may notice for Py, which is lying along the y-axis, the electron density is along the y-axis. For Pz, the electron density is along z-axis, and for dyz, the electron density in YZ plane. So therefore, for all these options Py, Pz and dyz, the electron density is in the YZ plane, whereas Px orbital you may consider this Px orbital is, if this is x-axis, this is y-axis, this is z-axis. For Px orbital, electron density is always along the x-axis, it lies along the x-axis. Therefore the answer for the particular question is Px. So given the explanation, the electron density of Px orbital lies along x-axis only. Thus the probability of finding the electron is maximum and lies only in the x-axis. Let us go to the next question. In which of the following pairs the two species are both isoelectronic and isotopic? Atomic numbers of the species are given. Option A, pair of species. Option B, pair of species. Option C, magnesium pair of species. Option D, sodium. And option E is about iron in different oxidation states. You may notice option A is giving you the same mass number for the species. Elements having same mass number, different atomic number, we call them as isobars, but the question is about isotope and isoelectronic, so it does not match. Option B, K plus and K plus both contain same number of electrons, namely the 18 electrons, therefore they are isoelectronic. And the number of protons in both potassium ions is 19 each, therefore they contain the same number of protons, atomic number is same, mass numbers are different, they are isotopes as well as isoelectronic. That is the correct answer for the question. And the other options, magnesium ions and sodium ions and iron ions in option C, D and E are all isotopic species, but they are not isoelectronic. Let us go to the next one. When the electron of a hydrogen atom jumps from n is equal to 4 to n is equal to 1 state, the number of spectral lines emitted is, the question is on number of spectral lines emitted, and therefore the formula to be used, n is equal to 4 to n is equal to 1, ground state is n is equal to 1. So formula to be used is n into n minus 1 by 2, that is equal to 4 into 4 minus 1 by 2 that is equal to 4 into 3 by 2, which is equal to 6. So answer for the question is 6. Let us find out what is that we have calculated, and it is the same calculation. When an electron jumps from n is equal to 4 level, the number of spectral lines given by 4 into 4 minus 1 by 2, that is equal to 4 into 3 by 2, that is 12 by 2, which is equal to 6. Shall I go to the next one now? The question is like this. The wave number of the spectral lines in the emission spectrum of hydrogen will be equal to 8 by 9 times the Rydberg constant of the electron jump. If the electron jumps from option A, n is equal to 3 to n is equal to 1, option B, n is equal to 10 to n is equal to 1, option C, n is equal to 9 to n is equal to 1, option D, n is equal to 2 to n is equal to 1. The spectral lines are calculated by the formula nu bar is equal to RH into 1 by n1 square minus 1 by n2 square. Here it is given the wave number of the spectral line in the emission spectrum of hydrogen will be equal to 8 by 9 times of the Rydberg constant. Therefore, 8 by 9 RH is equal to RH into 1 by 1 square minus 1 by n square. Simplify, RH get cancels, and you find 8 by 9 is equal to 1 by 1 square minus 1 by n square. Bring this 1 square on this side, it becomes 8 by 9 minus 1 is equal to minus 1 by n square. Simplify, you get minus 1 by 9 is equal to minus 1 by n square. That is 1 by 3 is equal to 1 by n. If it takes the square root, 1 by 3 is equal to 1 by 9, or n is equal to 3. Therefore, when the electron transition takes place from n is equal to 3 to n is equal to 1, you will find this answer in which option? That is found in option A. See the calculation I have made. Nu bar is equal to RH, and all the calculations, all the points are given. Use this formula. Nu bar is given, substitute the values, simplify, and you get this answer. The transition is taking place from n2 is equal to 3 to n1 is equal to 1. That is the correct answer. The probability density plots of 1s and 2s orbitals are given in the figure. It has not come out properly, and there should be dots here. The dots are missing. Let me put the dots here. And this is the sphere, you will find, and this is what the actual diagram should be. The density of dots in a region represents the probability density of finding electrons in the region. On the basis of above diagram, which of the following statements is incorrect? 1s and 2s orbitals are spherical in shape. It's a correct statement. The probability of finding electron is maximum near the nucleus. It is also a correct statement. The probability of finding the electron at a given distance is equal in all directions. It's a spherical orbital, therefore that is a correct statement. The probability density of electrons for 2s orbital decreases uniformly as the distance from the nucleus increases is not the correct answer. A reason for that given. This statement is incorrect. The probability density of electrons for 2s orbital first increases, then decreases, and after that it begins to increase again. So therefore, there is first increase, decrease, and then increase. That is the order that is followed. So option D is the incorrect statement for the diagram given there. Two atoms are said to be isobars if they have same atomic number but different mass numbers. They have same number of electrons but different number of neutrons. They have same number of neutrons but different number of electrons. Sum of the number of protons and neutrons is same, but the number of protons is different. So the answer is found to be In option D, isobars have the same mass numbers because the sum of protons and neutrons is equal to the same number what you get, but they differ in atomic numbers. The number of protons are different, so therefore you find them in isobars. The number of radial nodes for 3p orbital is option A 3, option B 4, option C 2, and option D 1. Question asked is a number of radial nodes. Number of radial nodes is given by the formula n minus L minus 1 for the L orbital. For S orbital, L is equal to 0. For P orbital, L is equal to 1. For D orbital, let me consider L is equal to 2, and for F orbital, L is equal to 3. So number of radial nodes is given by this. Number of angular nodes is given by the formula L for angular nodes. So the question is on radial nodes, therefore let me use this formula n minus L minus 1, that is equal to n. For 3p orbital, n is equal to 3 minus 1, that is equal to 3 minus 2, that is equal to 1. So the number of radial nodes is given by 1, that is in option D. Let me now go to the next question. The number of angular nodes for 4d orbital. Again, the question is on angular node. For angular node, the formula to be used is L. So for 4d orbital, n is 4, L is found to be, d orbital, L is found to be 2. So therefore L is equal to 2 is the answer. And let us verify what is that I have given in the answer. Answer is in option C. You find explanation. The number of angular nodes for 4d orbital is L is equal to 2. Let us move to the next question. Which of the following is responsible to rule out the existence of definite paths or trajectories of electrons? The first one, Pauli's exclusion principle. Option B, Heisenberg's uncertainty principle. Option C, Hund's rule of maximum multiplicity. Option D is Aufbau principle. So for the given question, answer is in option B, and that is Heisenberg's uncertainty principle. Heisenberg's uncertainty principle is known to you. It is simultaneously impossible to calculate both the momentum and the position of an electron. There is always uncertainty associated in the calculation. Therefore, it rules out the path traced by the electron. The total number in the next question, the total number of orbitals associated with third shell will be. Total number of orbitals associated is the question. Answer for the given question is calculated by the formula n square. Number of orbitals is the question asked, n square. Let me go to the previous slide. And the question is 3 square is given. What is that? 3 square is equal to n square, that is equal to 3 square is equal to 9. So the number of orbitals in the nth orbit is given by n square, that is equal to 3 square, that is equal to 9, and that answer is given in option C. That is the correct answer. Go to the next one. Consider the isoelectronic species Na plus, Mg2 plus, F minus and O2 minus. The correct order of increasing ionic radii is given. Option A, F minus less than, O2 minus less than, Mg2 plus less than, Na plus. Option B, Mg2 plus less than, Na plus less than, F minus less than, O2 minus. Option C, O2 minus less than F minus less than Na plus less than Mg2 plus. Option D, O2 minus less than F minus less than Mg2 plus less than Na plus. And these are all isoelectronic species containing 10 electron system. Therefore, you may find the correct order is found in option B, and one has to understand that in the case of isoelectronic species, with the increase in atomic number, nuclear charge increases, and with the increase in nuclear charge, electrons are pulled more towards the nucleus. Therefore, size of the ion decreases. In other words, ionic radius decreases. Therefore, the correct answer is in option B, Mg2 plus less than Na plus less than F minus less than O2 minus. That is, O2 minus has a larger ionic radius compared to any of the given ions. The order of screening effect of electrons of s, p, d and f orbitals of a given shell of an atom on its outer shell electron is in the order. Option A, s greater than p greater than d greater than f. Option B, f greater than d greater than p greater than s. Option C, p less than d less than s greater than f. Option D, f greater than p greater than s greater than d. And the answer for the given question is in option A, that is s greater than p greater than d greater than f. We shall now move to the next question. It is about ionization enthalpies. The first ionization enthalpies of sodium, magnesium, aluminum and silicon are in the order. We have already discussed about ionization enthalpy. The question is based on ionization enthalpy. Option A says Na less than Mg greater than Al less than Si. Na greater than Mg greater than Al greater than Si. Na less than Mg less than Al less than Si. Na greater than Mg greater than Al less than Si. So, you should understand ionization enthalpies increase across the period, but the increase is not regular. You may find the ionization enthalpy increases from sodium to magnesium, but magnesium has a higher ionization enthalpy than aluminum because of the electronic configuration. In magnesium, 3s2 configuration is there. It's a symmetric arrangement of electrons in 3s orbital, whereas in aluminum, one electron is found in 3p orbital, 3p1 electronic configuration. Therefore, the answer given, all that what I have told now is given in this paragraph of answer. Let me read out the second para there. Ionization enthalpy of magnesium is more than that of aluminum because the electronic configuration of magnesium is more symmetrical than aluminum. For magnesium, electronic configuration is 1s2, 2s2, 2p6, 3s2, whereas for aluminum, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p1, you may say, or 3px1. So, therefore, you will find in the case of magnesium, the symmetric arrangement is there. Whenever there is symmetrical arrangement, the electrons present in this type of arrangements are more stable. To remove electron from the highly stable state, you have to spend more energy. Therefore, the ionization enthalpy of magnesium is more than that of the next element, aluminum, in that period. We shall go to the next one. The statement that is not correct for periodic classification of elements is option A, the properties of elements are periodic functions of their atomic numbers. It is a correct statement. For option B, non-metallic elements are less in number than metallic elements, found to be true. For transition elements, the 3d orbitals are filled with electrons after 3p orbitals and before 4s orbital. Let us verify this. The first ionization enthalpies of elements are generally increases. Previous question we discussed, and it says it is not a regular increase, it is a general increase with increase in atomic number as we go down or as we move across the period. So, therefore, we find for the given question, the incorrect statement is in option C. Reason for this, the statement is not correct. For transition elements, 3d orbitals are filled after filling takes place in 3p as well as 4s orbitals. 3p orbital filled first, and then 4s, and then the 3d orbitals start to getting filled up. We shall go to the next question. Pauli's exclusion principle states that the nucleus of an atom is negatively charged. Electrons revolve around the nucleus in circular paths or circular orbits. Electrons enter into lowest energy orbitals. No two electrons in an atom can have all four quantum numbers identical. The question is about the statement of Pauli's exclusion principle. I think the answer you can identify easily in option D. No two electrons in an atom can have all four quantum numbers identical. Go to the next question. Among halogens, the correct order of the amount of energy released in electron gain, it means electron gain enthalpy, is F greater than Cl greater than Br greater than I. Option B, F less than Cl less than Br less than I. Option C, F less than Cl greater than Br greater than I. Option D, F less than Cl less than Br less than I. And we have discussed it already in synopsis. The correct answer is in option C, F less than Cl greater than Br greater than I. Among the halogens, this is the correct order for electron gain enthalpy. Now we shall go to the next question. A very interesting question we have. The formation of oxide ion O2 minus in gaseous phase from oxygen atom requires first an exothermic and then an endothermic step as shown below. O in gaseous phase plus electron gives O minus delta H naught is equal to minus 141 kilojoules per mole. O1 minus in gaseous phase plus electron gives O2 minus in gaseous phase. Delta H naught is plus 780 kilojoules per mole. Thus, the process of formation of O2 minus in gas phase is unfavorable even though O2 minus is isoelectronic with neon. It is due to the fact that option A, oxygen is more electronegative. Option B, addition of electron in oxygen results in larger size of the ion. Option C, electron repulsion outweighs the stability gained by achieving noble gas configuration. Option D, O minus ion has comparatively smaller size than oxygen atom. I find the answer is in option C, electron repulsion outweighs the stability gained by achieving noble gas configuration. O2 minus has 10 electrons as that of neon, but that stability is in fact is overcome by the repulsion between the negative charge on O minus and the negative charge of electron. Because of the repulsion, this particular formation of O2 minus by O minus 1 is an endothermic reaction. Therefore, stability is not to be considered here. We have to look into fact that there is a repulsion between the negatively charged oxide ion and the electron. We shall move to the next one. Electronic configuration of four elements A, B, C and D are given below. First one, 1s2, 2s2, 2p6, 10 electron system. 1s2, 2s2, 2p4, 8 electron system. 1s2, 2s2, 2p6, 3s1, 11 electrons are there. 1s2, 2s2, 2p6, and you find there are 1s2, 2s2, 2p5, 9 electrons in option D. Which of the following is the correct order of increasing tendency to gain electron? Increasing tendency to gain electron, four options are given A, B, C, D. Which is the correct answer? Answer you find all are having the electronic configuration shown. For the option A, it represents the element neon. Option B represents the element oxygen. Option C represents the element sodium. Option D represents the element fluorine. The correct order of electron gain tendency. And how to understand this? Left to right, electron gain tendency, you should remember electron gain tendency increases. So therefore, the correct order is A less than C, less than B, less than D. The density of a gas is 1.964 grams per decimeter cube at 273 Kelvin and 76 centimeter mercury. The gas is option A, ethane, option B, methane, option C, xenon, and option D, carbon dioxide. What is the answer? To get the answer for this, density is given. Rho is equal to 1.964 gram per decimeter cube. That means 1 decimeter cube weighs 1.964 grams. Therefore, what is the mass of 22.4 decimeter cube of the gas? That is 22.4 into 1.964. This is equal to somewhere around 44. It should be, because 22 into 2, it is almost equal to 2. 22 into 2 is nearly equal to 44, and 44 is the molar mass of carbon dioxide. So therefore, if you look at these options, option A, ethane, option B, methane, option C, xenon, option D, carbon dioxide, the answer should be for the carbon dioxide. Let us check that with the calculation made. Density is 1.96 gram per decimeter cube. Mass of 1 decimeter cube of the gas is 1.964 gram. The mass of 22.4 decimeter cube. Why should I calculate for 22.4 decimeter cube? That gives the molar mass, because we discussed already molar volume, molar mass, Avogadro number, mole, they are all interrelated. Therefore, calculate for mass of 22.4 decimeter cube of the gas. The answer you get is 1.964 into 22.4, that is equal to 43.99, and that answer is found in option D. Go to the next one. Another interesting question. A mixture of calcium chloride and sodium chloride weighing 4.44 gram is treated with sodium carbonate solution to participate all the calcium ions into calcium carbonate. Ca2 plus ion in the mixture in calcium chloride is converted to calcium carbonate. The calcium carbonate so obtained is heated strongly to get 0.56 gram of calcium oxide. Now see, calcium carbonate on heating decomposes to give calcium oxide, and what is the mass of calcium oxide formed? It is given 0.56 grams. The percentage of sodium chloride in the mixture with atomic mass of calcium as 40 is option A 30.6, option B 75, option D 69.4, option D 25. This is a lengthy calculation. Before I go to the calculation, let me explain how to answer this. If you go through the question once again, you can understand all the calcium ions are converted to calcium carbonate. The calcium carbonate is converted into calcium oxide, which weighs 0.56 grams. Therefore, you have to first calculate what is the mass of calcium in 0.56 grams of calcium oxide. Using this mass of calcium in calcium oxide, calculate the mass of calcium in calcium chloride. If you get the mass of calcium in calcium chloride, you know that mixture is given, of which is a mixture of calcium chloride and sodium chloride, whose mass is 4.44 grams. And if you remove the mass of calcium chloride from that, you actually get the mass of sodium chloride, and then you can calculate the percentage composition, and the working is done as follows. In calcium oxide, 56 grams of calcium oxide contains 40 grams of calcium. Therefore, 0.56 grams of calcium oxide contains what mass of calcium? That is, you may find 0.56 into 40 divided by 56. This is equal to 0.4 grams. So this is 0.4 grams of calcium written directly. This is how we calculate that as 0.4 grams. Or if you take 56 contains 46, or 0.56 grams of the oxide will contain 0.4 grams of calcium. Proceed. molar mass of calcium chloride. In that, atomic mass of calcium is 40, chlorine is 71. So, there you get the molar mass of calcium chloride as 111 grams. So, in 111 grams of calcium chloride, what is the mass of calcium? 40 grams. So, 40 grams of calcium is present in 111 grams of calcium chloride. Therefore, the 0.4 grams of calcium is present in 0.4 into 111 divided by 40, that is equal to 1.11 grams of calcium chloride. So, as I told you, we have first calculated the mass of calcium in calcium oxide, then the mass of calcium in calcium chloride. Now, I got the mass of calcium in calcium chloride, and finally, you use this mass of calcium chloride in calculation of the mass of calcium chloride in that mixture and calculate the mass of sodium chloride. Therefore, the mass of sodium chloride in the mixture is found to be 4.44, that is a combined mass, minus 1.11, which is equal to 3.33 grams. Therefore, the percentage of sodium chloride 3.33, which is mass of sodium chloride, divided by 4.44, that is the mass of the mixture given in this case, into 100, that is equal to 75. So, understand this technique carefully. It's an interesting question, and you have to solve as many numericals as you can of this type. The number of water molecules present in a drop of water containing 0.018 gram is. This is a question which is related to number of molecules and mass. Mass and molecules, you know, one molar mass of a substance contains Avogadro number of molecules. That is, what is the molar mass of water? Molar mass of water is 18 grams. 18 grams contains 6.022 into 10 power 23. Therefore, 0.018 gram contains how many molecules? That is equal to 0.018 into 6.022 into 10 power 23 divided by 18. So, if you simplify, and you will get this answer in option D, I believe. Let us verify that. See, answer given is option D, that is 18 grams of water contains 6.022 into 10 power 23 molecules. Therefore, the number of molecules in 0.018 grams of water is equal to 6.022 into 10 power 20. Another interesting question, the empirical formula, a molecular formula type. Empirical formula of a compound is given CH2O and its molecular mass is 90. The molecular formula of the compound is option A, C3H6O3, option B, C2H4O2, option C, C6H12O6, option D, CH2O. In this particular question, empirical formula is given directly, and we use the formula to calculate the molecular formula. The relation to be used is N into empirical formula is equal to molecular formula. The value of N is unknown. So, how to calculate the value of N? N is equal to molecular mass, that is given there, molecular mass divided by empirical formula mass, and you find this calculation is done as shown in the answer. The answer for the given question is in option A. How to get that? To calculate the value of N, molecular mass, as I told you, the ratio of molecular mass divided by empirical formula mass. Molecular mass of the compound is 90 divided by 30, that is equal to 3. So, to get the empirical formula, we don't need to calculate empirical formula, that is given already, that is CH2O. So, N is calculated. N into empirical formula is molecular formula. Therefore, value of N is 3, and multiply with that, you get this molecular formula of the compound as C3H6O3, the correct answer in option A. Go to the next one. 0.3 gram of an organic compound containing carbon, hydrogen and oxygen on combustion yields 0.44 gram of carbon dioxide and 0.18 gram of water. If 1 mole of compound weighs 60, then molar mass of the compound is CH2O, C3H8O, C4H6O, C2H4O2. And this question is not giving you the complete information. First you have to calculate the percentage of carbon, percentage of hydrogen and percentage of oxygen from the mass of carbon dioxide, water and the organic compound. Using this percentage composition, then calculate the ratio of atoms. How to calculate ratio of atoms? Percentage composition by atomic mass, and then you calculate the simple whole number ratio. The calculation is done as follows. Percentage of carbon, 12 by 44. What is this 12 by 44? 12 is the mass of carbon in 44 grams of carbon dioxide, because molar mass of carbon dioxide is 44. So molar mass of carbon dioxide is 44. How is this 44 you get? This is 12 plus 32. So 12 grams is present in 44 grams. 12 by 44 into 0.44 by 0.3. What is this 0.44? 0.44 is the mass of carbon dioxide that is formed in the reaction. 0.44 by 0.3 into 100. That gives you 40%. This 40 is the percentage composition divided by 12. What is this 12? 12 is the atomic mass. This gives you the number as 3.33. So 3.33 is the ratio of carbon atoms. Let us keep it as it is. Percentage of hydrogen, 2 by 18 into 0.18 into 100 by 0.3, that is equal to 6.66. That is the ratio of atoms. Percentage of oxygen, ratio of atoms you can say 0.66 divided by 1, that is equal to 6.66. And percentage of oxygen, 100 minus percentage of carbon plus percentage of hydrogen, that is equal to 100 minus 40 plus 6.66, which is equal to 53.44. So ratio of atoms is 53.34 divided by 16, which is equal to 3.33. Now, what is the ratio of atoms? How do I get 1:2:1? The least number in these three ratio of atoms, 3.33, 6.66 and 3.33 is 3.33. So ratio of atoms of carbon, hydrogen and oxygen, 3.33 by 3.33 is to 6.66 by 3.33 is to 3.33 divided by 3.33. So this is 1:2:1. So that is how you get this ratio of atoms as C1H21 or CH2O. So that will be the empirical formula. Empirical formula is CH2O. And we know the formula. Molecular formula is equal to N into empirical formula. Use this relation to get the molecular formula. To get the molecular formula, you require both the value of N and empirical formula. To get the value of N, molecular mass is given and it is given as 60. Empirical formula mass for this CH2O is found to be 30. So N is equal to 60 by 30, which is equal to 2. So therefore, molecular formula is equal to 2 into empirical formula, that is 2 into CH2O, which is equal to C2H4O2 is the correct answer for the given question, and that is found in option D. So we now go to the next one. What amount of dioxygen in grams contains 1.8 into 10 power 22 molecules? Again, the question is about the mass and molecules relationship. You remember, 1 molar mass always contain Avogadro number of molecules, or mass of Avogadro number of molecules is equal to molar mass. So therefore, this is how it is tackled. The answer for the given question is mass of 6.022 into 10 power 23 molecules of oxygen is equal to 32 grams. What is this 32? That is the molar mass of O2. So using this, now convert this mass of 1.88 into 10 power 22 molecules of dioxygen. So mass of 1.8 into 10 power 22 molecules of dioxygen is equal to how much? 1.8 into 10 power 22 into 32 divided by this number, Avogadro number, which is found to be 0.96. So the answer is in, you find in B, that is 0.96 grams. Here is the answer. Go to the next slide. If n is equal to 6, the correct sequence of filling of electrons will be n is equal to 6. Therefore, the answers given, option A, ns, then np, then n minus 1d, then n minus 2f. Option B, ns, then n minus 2f, then n minus 1d, then np. Option C, ns, then n minus 1d, n minus 2f, np. Option D, ns, then n minus 2f, np, and then n minus 1d. So, if n is equal to 6, means sixth period. So, which are the orbitals filled up in sixth period? You remember, in sixth period, the orbital that is first filled up is 6s, followed by 4f, followed by 5d, followed by 6p. So, if n is 6, that means ns, this will be n minus 2 into f, this will be n minus 1 into d, this will be np. Therefore, this order is found in this particular option. Let us verify, and I have given that particular order in the calculation made, and the explanation is given there. It is in accordance with the above principle. Electrons enter into various orbitals in the increasing order of their energy levels, and this order is found to be ns, then n minus 2f, then n minus 1d, np, and these are the orbitals which are filled up in the sixth period when n is equal to 6. All that explanation is available. Go through that once again clearly. Now we move on to the next slide. The question, what is the maximum number of electrons that can be associated with the following set of quantum numbers? Very interesting question. N is equal to 3, L is equal to 1, M is equal to minus 1. Answers, option A 10, option B 6, option C 4, option D 2. N is equal to 3, L is equal to 1. Clearly, it gives an idea that the orbital must be 3p. There are 3p orbitals. What are they? 3px, 3py, 3pz. But the value of m is also given in this numerical as m is equal to minus 1. So, for a given value of L, when L is equal to 1, the values of m are minus 1, 0 and plus 1. Therefore, you now understand, when m is equal to minus 1, it is 3px orbital. M is equal to 0, it is 3py orbital. M is equal to plus 1, it is 3pz orbital. So, in the given question, it is minus 1. That means it is 3pz orbital. 3pz orbital alone is possible for these quantum numbers. Any orbital can accommodate a maximum of 2 electrons. Therefore, this orbital possible is only one, that is 3pz orbital, and can accommodate only 2 electrons. And let us verify the answers given. The answer, I think, is given there, that is only 3pz orbital possible, and only 2 electrons are associated with these quantum numbers. N is equal to 3, L is equal to 1, and M is equal to minus 1. Questions of this type are repeatedly asked in the exams. Therefore, I suggest students to concentrate on these type of questions as well. Let us move on to the next slide. Which among the following factors is the most important in making fluorine the stronger oxidizing agent? Is it option A, electron affinity, option B, ionization energy, option C, hydration energy, and option D, bond dissociation energy? The answer for this question is, I find, in option C, that is hydration energy. When fluorine is dissolved in water, it forms fluoride ions liberating water of hydration. it undergoes hydration to a larger extent than any of the halogen atoms. And therefore, because of this, more amount of heat energy is liberated. It is found that fluorine acts as a strong oxidizing agent. Among the halogens, the heat of hydration is given for fluorine, chlorine, bromine, iodine as minus 515 kilojoules per mole, minus 348 kilojoules per mole, minus 347 kilojoules per mole, and minus 305 kilojoules per mole. It is in the decreasing order of magnitude. Fluorine with a higher magnitude is therefore a stronger oxidizing agent compared to the rest. When the electrons of hydrogen atom return to L shell from shells of higher energy, L shell the electrons are returning, understand this, L shell. We get a series of lines in the spectrum. The series is called Balmer series, Lyman series, bracket series, or option D, Bastian series. Which is the correct answer? K shell n is equal to 1. For L shell n is equal to 2. So that means n1 is equal to 2 and n2 is equal to electrons are returning from shells of higher energy. That means n2 will be 3, 4, 5, etc. And nu bar equation for this type is found to be 1 by n1 square minus 1 by n2 square, and the answer is this is 1 by 2 square minus 1 by n2 square. This is the expression you get for Balmer series. The correct answer I find is in Balmer series, and you find the answer given. The lines in spectrum are called Balmer series. Simple answer. You should understand that as soon as you look at this question and you find the letter L, n value should be 2. Based on that, you get this answer as Balmer series. Let us move on to the next slide. The mass of 112 centimeter cube of ammonia gas at STP is option A 0.085 grams, option B 0.850 grams, option C 8.5 grams, option D 80.5 grams. To get the answer, here mass and volume are related. To get this particular question, to get the answer for the particular question, we go like this. 22,400 centimeter cube of any gas weighs molar mass. So therefore, 22,400 centimeter cube of what is the gas given in this case? Ammonia weighs 17 grams. What is 17 grams? That is the molar mass of ammonia. Therefore, 112 centimeter cube of ammonia weighs what mass? That is 112 into 17 divided by 22,400. So if you simplify, you get this answer, and the answer worked out as follows. Look at this. Mass of 22,400 centimeter cube is 17 grams. For 112 centimeter cube, the answer is 0.085 grams, and it is found to be in option A. Let us go to the next slide. The number of oxygen atoms in 4.4 grams of carbon dioxide is option A 1.2 into 10 power 23, option B 6 into 10 power 22, option C 6 into 10 power 23, option D 12 into 10 power 23. Here the number of oxygen atom in 4.4 grams of carbon dioxide. The question is related to number of atoms and the mass. When the question is related to number of atoms and the mass, what is the relation that you have to use? And you remember, molar mass, 1 molar mass of any substance contains Avogadro number of molecules. Therefore, we understand 44 grams of carbon dioxide contains Na. Therefore, 4.4 grams of carbon dioxide contains how many? 4.4 into Avogadro number divided by 44. What is this Avogadro number? That is 6.022 into 10 power 23. Substitute and simplify, you get this number as 0.1. 4.4 by 44 is 0.1. 0.1 into 6.022 into 10 power 23, and simplify, you get this answer somewhere around 6 into 10 power 22. Let us verify that answer in the answer keys, and this is further oxygen atoms is the question asked, not the molecules alone. So molecules is what we get, 0.1 into 6.022 into 10 power 23 molecules. The question is on oxygen atoms. Then you find one molecule of carbon dioxide, one molecule of CO2 has two O2 atoms. You can see that two atoms. In one molecule of carbon dioxide, there are two oxygen atoms. For so many moles, how many oxygen atoms will be there? That is 2 into so many moles. Therefore, you find the number of oxygen atoms in this is found to be 1.2 into 10 power 23. Answer is found to be in option A. That is the correct answer. Go to the next slide. If 3.01 into 10 power 20 molecules are removed from 98 milligrams of sulfuric acid, then number of moles of sulfuric acid left are 1.66 into 10 power minus 3 moles, 0.1 into 10 power minus 3 moles, 9.95 into 10 power minus 2 moles, 0.5 into 10 power minus 3 mole. The question is, number of molecules are removed from 98 milligrams of sulfuric acid. You convert that molecules into mass. How to convert that molecules into mass? As I told you, the formula to be used. Avogadro number of molecules weighs molar mass. Using that formula, see, this is how I have worked out. For 98 milligrams of sulfuric acid, how many moles you get? 98 milligrams, converted that into grams, it is found to be 98 into 10 power minus 3 by molar mass, that is 98, which is equal to 1 into 10 power minus 3 moles. For 3.01 into 10 power 20 molecules is equal to 3.01 into 10 power 20 divided by 6.022 into 10 power 23. That is equal to 0.5 into 10 power minus 3 mole. Therefore, number of moles removed is found to be 0.5 into 10 power minus 3. The remaining number of moles is 1 into 10 power minus 3 minus 0.5 into 10 power minus 3 mole. That is equal to 0.5 into 10 power minus 3 mole. And the answer is found to be in question number D. So that is the very correct answer. Let us move on to the next slide, and hopefully that will be the last slide we can discuss. 1 gram of magnesium is burnt with 0.56 grams of oxygen in a closed vessel. Which reactant is left in excess and how much? The atomic masses are given. Option A, magnesium 0.44 grams. Option B, oxygen 0.28 grams. Option C, magnesium 0.16 gram. Option D, oxygen 0.16 gram. See, this is how that particular question is answered. According to the equation, 2 mg plus O2 gives 2 mgO. Or if you get the relation, you find 16 grams of oxygen requires 24 grams of magnesium. Therefore, 0.56 grams, in the numerical it is given 0.56 grams of oxygen requires how much of magnesium? 0.56 into 24 divided by 16, that is equal to 0.84 grams of magnesium. Therefore, magnesium is left unreacted, that is 1 grams of magnesium is given, out of which 0.84 is undergoing reaction. The remaining is 1 minus 0.84, that is equal to 0.16 gram. Therefore, magnesium is left in excess, and how much of magnesium is remaining? 0.16 grams. That answer is found in option C. So, in this way you answer these questions, and therefore with this I would like to conclude my CET class on these 3 important chapters, namely basic concepts, structure of atom, concepts, classification of elements I mean to say, and periodicity in properties. I have made some effort to make myself clear about these questions, and I hope I have given enough information to you students to understand and get an idea how to answer these questions on stoichiometry, and there is nothing to worry about if you are good in mathematics. Even if you are not good in mathematics, you can improve your skills, learn these formulas, memorize the formulas, understand tackling these numericals, physical chemistry, more of problems you get, and how to answer these numericals. You have to work more and more examples, and thereby you gain confidence, and when you get confident, you will answer questions happily. With this, I conclude my presentation. Thank you one and all.